In this video, we're going to use double and half angle formulas to establish identities and prove statements from 6.6. I have the whiteboard open just because they skip some steps in this, and I want to show you what they have done in each of these identities. So we're going to start off with this first one, which is like 6.6.51, and it says 2 sine cubed theta cosine theta plus 2 sine theta cosine theta is equal to sine of 2 theta. They want us to establish this identity, and I'd actually factor out my greatest common factor out front like this. They factor it out second, but it's okay. They say that if I take a sine and a cosine out, I'm left with a sine squared. And if I take a sine and a cosine out, this was cosine cubed, I'm left with a cosine squared like this. And so this is sine squared plus cosine squared is 1. 2 sine theta cosine theta is sine 2 theta by definition, times 1 is going to be sine 2 theta. So the closest thing to those steps there that we just took is A, where they factored out their 2 sine cosine, changed their cosine squared plus sine squared into a 1, and then multiplied, and they got their sine 2 theta. Again, you don't get multiple choice usually with identities, which is why I'm working things out on the board. So secant of 2 theta needs to be equal to cosecant squared theta over cosecant squared theta minus 2. They want you to start with the left-hand side and make it turn into the right-hand side. Not necessarily what I do, but let's go ahead and do that. This is going to be 1 over cosine of 2 theta. And cosine of 2 theta can be written in several different ways. That's why I don't like this method as much. But because we want to get the one that has cosecants over here, we probably want the one that has only sines in it, since sine and cosecant are related to one another. So this is going to be 1 minus 2 sine squared theta to replace the cosine 2 theta. And then we see that we want to get rid of the sine squared theta that's in the denominator. So we're going to multiply top and bottom by cosecant squared theta. When we do that, that's cosecant squared theta over cosecant squared theta minus 2. And that is equal to cosecant squared theta over cosecant squared theta minus 2. And those steps match closest with B, though they get a fraction over a fraction and multiply by the reciprocal. It's basically the same steps as what I did right here with multiplying by the unit fraction. So let's go ahead, and that was like 6.6, number 55. Let's look now at number 3. We want to establish the identity that cotangent squared of v over 2 is equal to secant of v plus 1 over secant of v minus 1. So we have a couple things going on here. We have a half angle identity here for cotangent. So let's say that that's going to be the reciprocal of 1 over tangent squared of v over 2, which is going to be equal to, by definition, 1 over 1 minus cosine of v over 1 plus cosine of v. That's what tangent squared of v over 2 will be, because tangent of v over 2 would be plus or minus the square root of this over this. So when I square both sides, I'm getting rid of the square root, but I'm going to multiply by the reciprocal, and that changes it into this. And then I'm going to change cosines into secants, because by multiplying by secant v over secant v, it's going to be secant v plus 1 over secant v minus 1, which is my right-hand side. And I have established my identity, and that's closest in steps here to what we do for B. Just they ended up getting fractions over fractions and multiplying by the reciprocal instead of multiplying by this unit fraction here, but it accomplishes the same thing. That is it for this video. We'll come back next time and we'll keep talking about 6.6. See you for the next video.